Welcome to another instructional video from OWL, the wise choice in fiber optic test equipment. I'm Professor Jim Powers. This video will help demonstrate how to check your micro OWL2 optical power meter for proper operation using a dual OWL multimode light source. It is always a good idea to check your patch cables and test equipment before testing for the day. Usually at the beginning of the testing day you want to check all of your equipment and patch cables and accessories. In this procedure we'll be using the micro OWL optical power meter and the dual OWL multimode light source. Now you'll see that there are three patch cables. There's two here, one here, and then a mating sleeve that we'll be using for this procedure. Okay, now because this is multimode, two of these reference cables are wrapped around a mandrel per testing standards, one for each of the wavelength included in the dual OWL. Now if you're testing at one wavelength, you will only need one of these mandrel wrapped cables. But since we're going to demonstrate both wavelengths, we have two mandrel wrapped cables. The straight cable will be used to connect the micro OWL power meter into the link under test, and the mating sleeve will be used to connect the reference cables to the straight cable for this procedure. Now, one thing you need to make sure of is that the test cables and mating sleeves are the correct connector style. They need to match the test equipment ports and the ports of the patch panel you'll be connecting into. Now, in this demonstration, we're going to be assuming that all connectors are SC. So, the first thing we do for this procedure is to power on the test equipment. So, for the micro OWL, we press on. Okay, and then for the dual OWL, we press the power button. Now, you'll see that the 850 nanometer LED is lit by default. And then as soon as the micro OWL finishes booting up, you'll see that there's an operating mode screen. There are several options. For this procedure, we're going to use simple meter. So, since simple meter is already highlighted, we press F2 to select. Okay. Now, the first thing you'll notice on the power meter here is that the display says under. Okay. What this means is that there's no measurable amount of light entering the photodetector. In other words, it's completely dark. You'll see that there is a dust cap on the detector port. This is why it says under. Now, if I take the dust cap off, you'll see that a reading will appear. Now, this reading is a little bit low. What it's doing right now is measuring ambient room light. There's no light source connected, so but any power meter is always taking measurements. So what it's doing now, it's just taking the fluorescent lighting in this room, and it's telling us how much of that light is there. But for what we want to do now is we want to connect the reference cables to the dual OWL ports here. Okay, the first thing we're going to do, we want to check the 850 nanometer cable here. So what we'll do, we'll locate the 850 nanometer cable and we'll plug it into the detector port on the micro OWL. Okay, you will notice that you have a power reading here, minus 19.36. Okay, so this is actually an acceptable reading. We don't want to be any lower than minus 21 here. We want to make sure that the patch cable is good, and the acceptable value should not fall below minus 21. Our target value is around minus 20 dBm. So now that we've checked our 850 nanometer cable, we'll disconnect that and put the dust cap on. It's always a good idea to replace dust caps. And then we'll plug in the 1300 nanometer reference cable. Okay, you'll see that it says under. Again, there's no measurable amount of light coming into the detector. This time it's because we haven't switched the light source over to 1300. So, to check the 1300 nanometer cable, we simply change the wavelengths on both devices to 1300 nanometers. On the dual OWL, we just press the lambda button one time, and it switches over to the right-hand side, you'll see here. And then on the micro OWL, we'll press the F3 button twice, and you'll see that it says 1300 nanometers now. Now, this patch cable is reading around minus 19.85. Still acceptable. It's very close to minus 20 dBm, and it's not below minus 21 dBm. So we can be assured that both of these reference cables are proper and good, and we can use them for our measurement. Now what we need to do is make sure that our straight cable this one right here, the one that's used to connect the micro owl into the test, we have to make sure that one's good as well. Now to do that, we need to temporarily zero out our patch cable, our reference cable here, and then connect in our straight cable. So first thing we do, to zero out at this wavelength, we'll use the 1300 wavelength to check this. You can do this easily by two different ways on the micro owl. Either you can press the F2 button, notice it says 0 here, or you can press the 0 key. That will do the same thing. So we'll press F2 to 0, okay, and we'll be asked to set a 1300 nanometer reference. Okay, and we want to do that, so we'll press F1 to confirm. And you'll notice that the display changed to 0, but now it says dB instead of dBm. dB is what you use to measure loss. You're not measuring the total optical power now. You're measuring how much loss you have in link. Now, the reason we say 0 is because we're measuring at our reference level. It's our starting point. So once we insert a cable in between this reference cable and the micro owl, that will be the loss of our link. But for this purpose, for checking our equipment, what we'll do is we'll just insert our test cable here. So we have to take the patch cable out of the detector port. Again, notice it's measuring ambient room light. That's normal. We'll plug the adapter onto the end of the reference cable. We'll take the straight cable. We'll plug that into the end of this mating sleeve. And finally, we'll take the other end of this test cable. We will plug into the detector port. Okay. Now, notice that we have a reading of 0.00 dB, even though we've taken a patch cable and an adapter and plugged it in. So what this means is that you have a near perfect patch cable in order to connect the micro owl into the link under test. So now that we've done all of this procedure, we've checked our patch cables, we've made sure that they're okay. So now we can use these patch cables to do our measurements.
If the power level falls below the acceptable power level range, debris such as dust, dirt, or finger oil may have collected on the connector end face or in the equipment's optical ports. Thoroughly clean and inspect all connector end faces and equipment's optical ports according to industry standard cleaning procedures. Several cleaning cycles may be required. Keeping connectors and optical ports clean at all times helps to keep test equipment in good working order and proper calibration, ensuring accurate and reliable test results. When not in use, dust caps should be kept on fiber connectors and optical ports to keep debris from collecting on the surfaces of the connectors and ports. During testing, it is highly recommended to clean and inspect both connectors and optical ports every time a connection is made. Failure to properly maintain your test equipment could needlessly result in costly repairs. For example, over time, repeated connector insertions into a dirty optical port could grind the debris into the optics in an equipment port. This type of damage is permanent and cannot be repaired in the field. If the problem still exists after thorough cleaning and inspection, the patch cable may need to be replaced. Patch cables are typically rated for a few hundred connector insertions, but can prematurely wear out or become damaged if they are not properly handled and maintained. If the power level is still too low, even after patch cable replacement, contact OWL Technical Support for assistance. This has been another instructional video from OWL, the wise choice in fiber optic test equipment. For more information about additional instructional videos or OWL fiber optic test equipment in general, please visit OWL's website at owl-inc.com. I'm Professor Jim Powers. Thanks for watching.